Good morning to one and all. See this today in this live lecture we shall discuss the next important equation in the ordinary differential equation. Next important equation, that is the Legendre equation. Now how to solve, we shall discuss how to solve the Legendre equation. Actually this is a particular type of equation which is frequently used in the solution of some physical problems, or frequently used in the physics series. But in this mathematics we shall discuss how to solve this Legendre equation. There is a separate theory, there is a separate procedure to find the solution of the Legendre equation. And see that, note that Legendre is a particular type of a second order differential equation specified by the scientist, that is a Legendre, and we have to here solve the Legendre's equation. Now how to find out the solution of a Legendre equation we shall discuss here. Now see here, in particularly Legendre equation having, say this is the actually last bit of that unit number second. Tomorrow there is holiday, that is due to the Sunday. We shall take extra lecture in tomorrow, I think nearly about 10 and 12. There will be 2 extra lectures we shall conduct tomorrow, because we have to complete our syllabus, that is up to the 5 April, I think 5 April. So it is necessary to conduct the extra lecture. क्या सद्दाम जी आप है, मनीषा माली, सद्दाम, पूजा, नेहा, माने. Okay. Now see this is the particular type of a Legendre equation. Now some of the important differential equation we got in the physical phenomena, particular type of a nature of the curves are in second order. Sandesh, Sandesh, are in second order. So we have to find some of the important differential equation met in the physical phenomena in the physical problems are in second order differential equation. जरी अपन जनरली, आपको पता है हम बहुत सारे इक्वेशन जनरल मेथड nth ऑर्डर डिफरेंशियल इक्वेशन को यूज करते हैं, लेकिन जनरली हमारे पास सेकंड ऑर्डर डिफरेंशियल इक्वेशन ज़्यादा होते हैं, बिकॉज हम जो वेव जो होते हैं, वेव्स जो फिजिक्स में जो किसी भी प्रॉपर्टी, ऑब्जेक्ट की प्रॉपर्टी वगैरह आपको डिस्कस करना है तो वेव के बारे में डिस्कस होता है, एंड अकॉर्डिंग टू द वेव वी कैन find the solution, we can observe the nature of particular matter, but that wave can be obtained in the two-dimensional system, generally in the two-dimensional system. So here the frequently used equation, that is second order linear equation with analytic coefficients, one of these equation is called as a Legendre equation. See this. And that Legendre equation is particularly, we can say, see this is the Legendre equation, that is L of y, which is equals to 1 minus x square into y double dash minus 2x y dash plus alpha into alpha plus 1 into y. Suppose this is a constant. Now we have to convert this equation in the form of y double dash plus a1 of x y plus a2 y dash plus a2 of x y, which is equals to 0. We have to dividing by the coefficient of this 1 minus x square. Now dividing this coefficient 1 minus x square, it is the coefficient of y double dash, which is generally denoted by a0 of x. But in the last lecture, yesterday we have seen how to find out the solution of a differential equation which is in the second order differential equation having the analytic coefficient. See this, yesterday we have completely seen how to solve the second order linear differential equation having the analytic coefficient, and we have solved that equation according to the condition that is g of x is equals to summation k is equals to 1 to n ck into x minus x naught bracket raised to k, where the radius x minus x naught mod of x minus x naught is less than, see this, mod of x minus x naught is less than r naught, where r naught is the radius of a convergence. We have seen in the last lecture. And according to the g of x, we can write phi 1 of x. By taking the derivative phi 1 of x, then we can take phi 2 dash of x, phi 1 dash, phi 2 dash, and put this value phi 1, phi 2, phi in the given differential equation in the analytic form, then we get the solution. One example which also we have seen in the last lecture. तुम्हाला आठवतं का पाय, हे लास्ट लेक्चर मध्ये सुद्धा पाहिलेलं आहे. सांगा रे काय असतो analytic coefficient? We have seen. So the value of phi of x, सांगा बरं, what is the, in the analytic coefficient we can put phi of x is equals to some particular constant, so particular series. What is that series, you tell me? And in that case, in the analytic coefficient, if we consider phi of x, then in that case x0 or x naught is called as the initial solution. Okay, no problem. Now we shall discuss this. Now dividing by 1 minus x square on both sides of this equation, then we get, what is that equation? So we get L of y which is equals to, यहाँ पे है देखो, L of y which is equals to y double dash minus 2x upon 1 minus y dash. We can write this also. See this, y double dash minus 2x, see this, 2x divided by 1 minus x square into y dash plus alpha into alpha plus 1 divided by 1 minus x square into y which is equals to 0. Students, आपको याद रखना है, this is the particular theory for the solution of Legendre's equation. Question may be asked in the way, state the Legendre equation, Legendre's differential equation, and write it's the solution method. Okay, write it's the solution method, or solve this Legendre's differential equation. That means this is for 15 marks. हे खूप मोठी थेरी है, वेगळी थेरी है, पर्टिकुलर थेरी है. एक्चुअली ये पर्टिकुलर थेरी है लीजेंड्रीज इक्वेशन सॉल्व करने के लिए, और हमें यहाँ पे लीजेंड्री इक्वेशन सॉल्व करने के लिए हमें एनालिटिक कोएफिशिएंट का सहारा लेना होता है. उसी तरह से इसको सॉल्व करना है. ठीक है, देखो अभी देखो, y डबल डैश माइनस 2x डिवाइड बाय 1 माइनस एक्स स्क्वायर इंटू वाई डैश प्लस अल्फा इंटू अल्फा प्लस 1 divided by 1 minus x square into y which is equals to 0. Suppose this is equation number 8.1, or we can write 1 also. त्याला तुम्ही equation number 1 भी देऊ शकता किंवा 8.1 द्या, because we have considered this Legendre equation. This is our 8th number bit in our syllabus, so we can write this equation 8.1, 8.2, no problem. Now see here we note that the functions, that is a variable coefficients, a1 of x and a2 of x are given by, a1 of x means this coefficient of y dash which is denoted minus 2x upon 1 minus x square, and a2 of x means this is a coefficient of y which is given by alpha into alpha plus 1 divided by 1 minus x square. Now these coefficients are said to be analytic at x is equals to 0. If we put x is equals to 0 in these functions, then a1 of x goes to 0. a1 of x goes to 0, and a2 of x is equals to alpha into alpha plus 1, means we get the constant coefficient. here. That is a1 of x goes to 0 and a2 of x becomes, that is alpha into alpha plus 1. So we can say that these are the analytic coefficient at x is equals to 0. It is a very essential condition to obtain the analytic coefficient here. To get the analytic coefficient a1 of x, a2 of x, it is necessary to put x is equals to 0. That means under x is equals to 0, then we can express this analytic coefficient. That means the initial value is series. Therefore, the initial value is suppose x. Now, we can write the series for 1 upon 1 minus x square. How to write the 1 upon 1 minus x square? 1 upon 1 minus x square can be written as in the expansion form 1 plus x square plus x fourth plus x sixth dot 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 dot. In this way, summation k is equals to, आता हे जे तुम्हाला माहित आहे 1 upon 1 minus x square can be written in the series form 1 plus x square plus x raised to 4 plus dot 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 dot. Okay, that is summation k is equals to 0 to k is equals to infinity x raised to 2k. Means these are the even power 2. If we put x is equals to 0, then k is equals to 0, then x raised to 0 gives a value 1. If we put k is equals to 1, then x raised to 2 into 1 which gives a value 2. x raised to अगर 2 put करते हैं तो 2 into 2 4 which gives a value this. So this is the expression summation form of 1 upon 1 minus x square. If the series converges, for mod x which is less than 1, अगर आपको पता है इस तरह के लिमिट हमने सॉल्व भी किए हैं, this series converges if the modulus of x which is less than 1. If x is greater than 1, then this series goes to divergent. म्हणजे ही series convergent कधी होते? x is less than 1. We have seen in the chapter B.Sc second year how to write the series of convergence and divergence. See this type of problem we have seen there. This series is convergence at x is less than 1. Okay. Now we can write this a1 of x, a2 of x in such a way that, see this a1 of x is equals to summation k is equals to 0 to infinity minus 2 into x raised to 2k plus 1. How will we get this? Because we know that only the value of this series, मी explain व्यवस्थित करतो, तुम्ही समजून घ्या. We know that the value of this 1 upon 1 minus x square which is equals to this, but we know that a1 of x is equals to 2x upon, so we can write this implies that 2x upon 1 minus x square, this can be written in a summation form. काय करावं लागेल रे इथं सांगा, दोन्ही साइडला आपल्याला 2x न मल्टिप्लाय करावं लागेल. समेशन फॉर्म किती न मल्टिप्लाय करायचा? -2x. यहाँ पे देखो -2x न मल्टिप्लाय करा, सो -2x into x raised to 2k. So this -2 can be written as it is summation. We can write this x into x raised to 2k means x raised to 2k plus 1, and this is a1 of x. So we can take a1 of x is equals to in the summation form as it is in this way. So we have expressed there a1 of x is equals to -2 into x raised to 2k plus 1. Similarly, we can write a2 of x is equals to k is equals to 0 to infinity, because 1 upon 1 minus x square, see this 1 upon 1 minus x square can be written as x raised to 2k, and we have to multiply by alpha into alpha plus 1. This is a coefficient in A2 of x. So आता फ्रॉम फास्ट घेतो, खूप मोठा प्रॉब्लेम आहे, समजून घ्या, कुठं जर अडचण आली तर विचारा. नाउ विच इज कॉन्व्हर्जेस फॉर mod of x less than 1. Now we know that from the theorem number 12, it follows that in the analytic, we follows that the solution of L of y is equals to 0 when mod x is less than 1 has a convergent power series. Yesterday we have seen this theorem. In that theorem, analytic solution of the analytic expansion, we proceed the basis solution of L of y. Let phi be the solution of Legendre equation on mod of x. Actually here x means what? X minus x naught is less than r naught. R naught means 1. X naught means initial value, solution, initial solution, that is x0. So x minus x naught is less than r naught, which gives the radius of a convergence. But in this Legendre equation, x naught is the initial condition and radius of the convergence is less than 1. So we can write this mod x is less than 1, and suppose we know that phi of x is equals to expansion series C0 plus C1 of x plus C2 of x square plus dot dot dot. How we can write this? We can write this as Ck. Actually we have obtained, we can write this summation over k is equals to 0 to n. Yesterday in the theorem number 12 we have seen that phi of x is equals to Ck into x minus x naught bracket raised to k. See this? Or we can write g of x is equals to summation k is equals to 0 to n Ck into x minus x naught bracket raised to k. Yesterday we have seen this. तुम्हाला आठवत आहे का? काल theorem मध्ये पाहिले. Now use that theorem. If we put x is equals to 0, then we get x naught is 0. X naught is 0. So we can write this summation as k is equals to 0 to n Ck into x raised to k. This is, we have seen, if the coefficients are analytic, then we can write the solution phi of x in the summation form of the series k is equals to 0 to n Ck into x minus x naught bracket raised to k, which is equals to k is equals to 0 to n Ck x raised to k, because x naught is initial point which gives the value 0. Now expand this. If we put 0, x is, now use this summation, x is equals to 0, that is C0, C1, C2 in this way. That means we can write this in the summation form. Now if we differentiate this, अभी इसको क्या करना है, आपको differentiate करना है इसे. Now if we differentiate this, इथं मात्र लिहा रे students, phi of x is equals to summation over k is equals to 0 to n Ck into x minus x naught bracket raised to k, according to the analytic coefficients. Now differentiate this. We can write, if we differentiate this, then phi dash of x is equals to C0 का, C0 is a constant term, so its derivative is 0, so there is no any appearance of C0 in phi dash of x. Now see this C1 of x. C1 of x means C1 is a constant coefficient, derivative of x is 1, so C1 of x means C1. Now C2 of x means C2 of x square means 2 times of C2 of x. C3 of x cube means 3 times of C3 of x square. C4 of x raised to 4, then we can write this as a 4 into C4 of x raised to 3. In this way we can obtain. समजतंय का रे? अक्षदा साठे, मस्केलिनता, समरीन खान, हे आठव समजतंय ना? काल आपण याच पद्धतीने घेतलं होतं. सेम आहे, फक्त फरक एवढा आहे की हे लिजेंड्रीज इक्वेशन पर्टिक्युलर टाइपचं असतं. You must note that Legendre equation is L of y which is equals to 1 minus x square bracket square y dash, 1 minus x square into d2y by dx square minus 2x square divide 2x square into y dash plus alpha into alpha plus 1 into y which is equals to 0. This is a particular type of equation. So that equation is called as a Legendre equation. एक्झाम मध्ये विचारतात पहा, एक्झाम मध्ये विचारतात विच ऑफ द फॉलोइंग इज क्वेश्चन ऑब्जेक्टिव्ह टाइप मध्ये असं सुद्धा विचारतात विच ऑफ द फॉलोइंग इज द Legendre equation. Means this is the process for shortcut and this is the solution method. Here Legendre equation satisfies the condition of analytic coefficient when x is equals to 0. So we have to take the initial solution x is equals to 0. Then yesterday in the theorem number 12 we have seen that we can write the solution phi of x. If the coefficients are analytic, then we can write the solution phi of x is equals to summation k is equals to 0 to n ck into x minus x naught bracket raised to k. X naught is here 0, so we can write this in this way. आता याला पुन्हा हे phi dash of x आहे, याला -2x न मल्टिप्लाय केलं दोन्ही साईडला. कशामुळे -2x न मल्टिप्लाय केलं लक्षात येतं का तुम्हाला? तिथं पहा इक्वेशन असं आहे -2x डिवाइड बाय 1 minus x square into y double dash, y dash. So it can be written as a phi dash of x. मग phi dash of x ला हे 2x न मल्टिप्लिकेशनची गरज होती. बाकीचं तर कोएफिशिएंट आपण एक्सपान्शन सिरीज मध्ये घेतलेलाच आहे. सो वी कॅन राईट दिस एज हियर मल्टिप्लाइंग बाय 2x, देन वी गेट 2x इंटू phi dash of x इज इक्वल्स टू या साईडला सुद्धा 2x न मल्टिप्लाय करा. 2x न मल्टिप्लाय केल्यामुळं इथं पहा मी सांगतो तुम्हाला जनरल थेरी कशी आली. ओका, याचा डेरिव्हेटिव्ह घ्या. काय डेरिव्हेटिव्ह घेतल्यानंतर कसा येतो डेरिव्हेटिव्ह? k इंटू सी के एक्स रेज टू के मायनस 1. आता याला जर पुन्हा 2x न मल्टिप्लाय केलं दोन्ही साईडला के मायनस 1 प्लस 1 मीन्स एक्स रेज टू के मायनस 2k सी के एक्स रेज टू के. 2x न मल्टिप्लाय केलं दोन्ही साईडला मल्टिप्लाइंग by minus 2x because minus 2x is the coefficient of y dash. Also we have to find phi double dash, means we have to take differentiation of this equation. Phi dash चा पुन्हा derivative घ्या. c1 is a constant term, so its derivative 0 we cannot take here. c2 of x means its derivative is c2 plus c3 c2 x square means we can write 3 into 2 into c2x in this way. Then we get the result as याचा आपल्याला असा रिझल्ट मिळतो k is equals to 0 to 1 0 to infinity k into k minus 1 ck into x raised to k minus 3. So this can be, we can write the equation number 8.4. say this म्हणजेच x square न मल्टिप्लाय करा दोन्ही साईडला x square न मल्टिप्लाय केलं तर पुन्हा minus x square into phi double dash of x which is equals to summation k is equals to 0 to infinity minus k into k minus 1 ck x raised to k. Okay, so we can write this. Note that phi double dash of x may be written as, अभी इसका phi double dash जो है ना हम इस तरह से भी लिख सकते हैं. सो phi double dash of a x is equals to summation k is equals to 1 to n k plus 1 into k plus 2 into k plus 1 c k plus 2 bracket raised to x. This is suppose equation number 8.5. Now from 8.2 and 8.5 we are to use this 8.2 and 8.5 in the equation of the Legendre form. So L of phi of x is equals to 1 minus x square into phi double dash minus 2x into phi dash into alpha plus 1 phi double dash. So see this is the Legendre equation and phi is the solution. So we can write the Legendre equation in terms of a phi. Now put the value of phi double dash We can write this value. See this, Ck, Ck2, and x raised to k is, we have taken the common here. X raised to k is taken common here. Also put the value of phi dash. The value of phi dash is k into k minus 1 Ck. Then there is also x raised to k, which is we have taken common, and also alpha into alpha plus 1 into phi. Alpha into alpha plus 1 into phi. Again there is a x raised to k in phi of x. See this. In phi of x we can put x raised to k. See this, phi of x. Summation k is equals to 0 to infinity Ck into x raised to k. Now multiplying by alpha into alpha plus 1. Alpha into alpha plus 1. इथं alpha into alpha plus 1 न मल्टिप्लाय केलं तर काय होतं हे? मी इथं लिहितो ना. So alpha into alpha plus 1 into phi of x, which is equals to summation k is equals to 0 to infinity alpha into alpha plus 1 into Ck x raised to k. यातला x raised to k आपण कॉमन घेतला. So we can write this as x raised to k कॉमन घेतला, इथं राहिला alpha into alpha plus 1. This is the second term, and in this way we can obtain the values. Okay, so we get this summation form or series expansion for L of phi of x. Now see here, for phi satisfy L of y is equals to 0, because this is the homogeneous. You note that. हाँ, सर्व विद्यार्थी मला पाहू द्या रे, कोण कोण ऑनलाईन आहेत. लिजेंड्री इक्वेशन हे होमोजिनियस आहे. आत्ताच मी लिजेंड्री इक्वेशनचा फॉर्म लिहिला होता. तो होमोजिनियस आहे का नॉन होमोजिनियस आहे सांगा बरे. चला फर्स्ट, नाउ यू टेल मी द लिजेंड्री इक्वेशन इज आइदर होमोजिनियस और नॉन होमोजिनियस. सभी ने चैट बॉक्स में आंसर लिखना जरूरी है, मुझे देखना है कौन कौन लेक्चर कंसंट्रेशन से कर रहा है. सो लीजेंड्री इक्वेशन, नाउ फॉर phi satisfies L of y is equals to 0, we must have the coefficients of the power of x equal to the 0. Power of x is equals to 0. So L of y is equals to 0. Then we have to write this as L of y is equals to 0. That means L of phi is equals to 0. Because legendary equation is homogeneous. Then we can write, very good, Rutika Tatewar, Adnya, Sarika Bolegave, very good. It is the homogeneous equation. So we can write L of y is equals to 0. That means L of phi is equals to 0. So this will be 0. अगर ये 0 है, इसका मतलब होता है इसकी सभी जो कांस्टेंट सीरीज एक्सपेंशन है ये सभी 0 होते हैं. ये सभी 0 होते हैं. एंड k x raised to k, यहां पे x raised to k आता है. सी दिस x raised to k, but it is not equals to 0. Then we can replace this out of the denominator, then that goes to 0. X raised to k goes to 0. So we get only the terms of a constant. Terms of constant. See this. समजता का पहा? So we can consider this equation as 8.6. See this. This equation is 8.6. Thus we get, suppose this is 8.6. For k is equals to 1, 2, 3. Now how to calculate this constant coefficient? We have seen also. आता हे कॉन्स्टंट कोएफिशिएंट सीरीज मधले कसे कॅल्क्युलेट करायचे हे तुम्हाला माहितच आहे. सो दिस इज अ Ck plus 2, that is a Ck. Then how to calculate this? See this, addition of these two terms is equals to 0. ये देखो, ये दोनों टर्म के एडिशन 0 है. इसका मतलब फर्स्ट टर्म मस्ट बी 0 and second term must be 0. Then we get the addition of two terms equals to 0. ये देखो यहाँ पे दो terms है addition में. First term is this and second term is this. Second term is that. So addition of both term is 0. That means first term must be 0, second term must be 0. And according to this condition we can find the value of Ck. Ck means C1, C2, C3. So we can write this as, समजून घ्या, खूप मोठा थेरम आहे हा, खूप मोठा थेरम आहे. दिस इज द रिकर्शन रिलेशन gives Ck plus 2 in terms of Ck for k is equals to 0, then we can obtain C2 is equals to minus alpha plus 1 into alpha divided by 2 into C0. Okay, we can write the equation Ck. We can write the equation Ck. By using this, we can write equation this. Ck plus 2. आता याला इकडे लेफ्टला घ्या, k इज इक्वल्स टू 0 ठेवा, Ck प्लस 2 इज इक्वल्स टू, असं पण लिहिता येईल पहा, मी इथं लिहून दाखवतो वाटलं तर. दिस कॅन बी रिटन ॲज, सी दिस, दिस कॅन बी रिटन ॲज Ck प्लस 2 विच इज इक्वल्स टू, आता हे राईट साईडला घ्या, वी कॅन टेक अल्फा प्लस के प्लस 1 into k minus alpha. Alpha minus k can be written as k minus alpha. ही पॉझिटिव्ह टर्म निगेटिव्हला झाली. डिवाइड बाय k plus 2 k plus 1 into C0. Sorry, we can write Ck. This is a Ck. This is a relation for Ck plus 2, that means Ck plus 2 which is equals to, हे समजतं का रे स्टुडंट्स, मी कसं काढलं याच्यावरनं, वी कॅन फाइंड द व्हॅल्यू ऑफ Ck प्लस 2. ही जी पॉझिटिव्हची टर्म आहे राईट साईडला घ्या, निगेटिव्ह होते. पॉझिटिव्हची टर्म राईट साईडला घ्या, निगेटिव्ह होते. आणि हे मल्टिप्लिकेशन खाली डिव्हिजनमध्ये जातं, म्हणजे Ck प्लस 2 इज इक्वल्स टू अल्फा प्लस के प्लस 1 मायनस के मायनस अल्फा डिवाइड बाय के प्लस 2 इंटू के प्लस 1 इंटू Ck. आता मी काय करेन, आता मी इथं काय करेन, k इज इक्वल्स टू 0 ठेवेन, k इज इक्वल्स टू 0 ठेवेन, अल्फा इज एनी टर्म, सो वी गेट फॉर k इज इक्वल्स टू 0, सीरीज फॉर k इज इक्वल्स टू 0 वी गेट द रिलेशन. पहा आता त्यामध्ये जर तुम्ही k इज इक्वल्स टू 0 ठेवलात तर रिलेशन काय होतं पहा, आठवतंय का तुम्हाला, that is Ck plus 2 which is equals to, that is alpha plus k plus 1. आता हे मायनस जर घेतला इकडं, मायनस आला, k मायनस अल्फा डिवाइड बाय k प्लस 2 इंटू के प्लस 1. ही स्टेप एक स्टेप लिहामध्ये ॲड करा नंतर, म्हणजे लक्षात येतं तुम्हाला. डायरेक्ट C2 कसं आलं नाही समजणार, C2 कसं आला समजणार नाही, म्हणून एक स्टेप ॲड करा. इंटू सपोज दिस इज Ck. नाउ इफ वी पुट k इज इक्वल्स टू 0, देन वी गेट द रिझल्ट. आता यात k इज इक्वल्स टू 0 ठेवा, मीन्स C2 इंटू, now k is 0 means alpha plus 1, k is 0, 0 minus alpha means minus alpha, minus can be put here, then we get the relation this. Okay, now we can write, similarly we can write alpha 3, if we put k is equals to 1, then we get alpha 3, if we put k is equals to 2, then we get this, k is equals to 3, then we get this. In this way we can write 8.6. तुम्ही याला 8.6 अगोदरच्याला मानण्याच्या ऐवजी याला जरी मानलात तरी 8.6. दिस इज फ्रॉम 8.6. दिस इज ऑब्टेन्ड फ्रॉम 8.6. हां, तर हे C4, C5, C1, C2, C3, C4, C5, in this way we got the values of a constant in this way. So we get, observe that C4 negative, C1, C2 negative, C3 negative, C4 negative, C5 negative. In this way we can write the value of C1, C2 in the form of, again we can replace this in the form of C0, C1. So we can write C2m is equals to minus 1 raised to m into in this way. We can generalize this. And C2m minus 1 means we can generalize in this way. By using the denominator's factor form, we can generalize this. Okay. म्हणजे odd term असेल तर this, even term असेल तर this. So we can write all the values of C1, C2, C3. Thus, we get by using the values of C1, C2, C3, we can write the solution in the form phi is equals to C0 phi1 of x plus C1 phi2 of x, because we know that Legendre equation is, see this, Legendre equation is in second order differential form, so it has two basic solution, two independent solution, phi1 and phi2, because Legendre is having second order differential equation. म्हणून इथं phi1 आणि phi2 आले, phi3, phi4, phi5 येत नाही त्यामध्ये. यहाँ पे phi1 and phi2 are only two solution, five independent solution. Why we can say that phi1 and phi2 are two independent solution? Because Legendre equation is of order second, so it has only two independent solution. It has only two roots, r1 and r2, or it has two solutions, phi1 and phi2. So phi1 of x can be written as in this way. Means how to write this phi1 of x? That is C0, C1 of x, C2 of x. In this way we can obtain the value. So phi1 of x means we can differentiate this. Phi1 of x we can write in the form of general term, in the form of m. m च्या स्वरूपामध्ये असं लिहिलं जातं. So we got the result in this way. Phi2 of x is equals to this. Phi2 of x is equals to this. So we can write in the general form, phi2 of x is equals to in the form of m. 2m plus 1 आता लिहिलेला आहे. From this we can write, from this c 2m and c2m plus 1. So we can write by using this phi1 of x, we can write by using this phi2 of x. Okay. So we get the phi2 of x. Thus both phi1 and phi2 are, see this, thus both the phi1 and phi2 are solution of the Legendre equation corresponding to the choice. Now if C0 is equals to 1, C1 is equals to 0, and C0 is equals to 1, C1 is equals to 0, we can take this C1 is equals to 0 respectively. Then the basic solution will be phi1 of 0 is equals to 1, phi2 of 0 is equals to 0, phi1 dash of 0 is equals to 0, phi2 dash of 0 is equals to 1. If we put C1, C2 in that equation, then we get the result. We notice that alpha is a non-negative even number, so n is equals to 2m, m is equals to 0 to 1. Then we get phi1 has a finite number of 0 term. Indeed, in the case of phi1 is a polynomial of degree n containing the even power of x. For example, phi1 of x is equals to 1. Phi1 of x is equals to 1 minus 3x square. If we put alpha is equals to 0, if we put alpha is equals to 2, then we get phi1 of x is equals to 1 minus 3x square. Put this alpha is equals to 2 in that equation, and alpha 1 is equals to, if we put alpha is equals to 4, then we get 1 minus 10x square plus 35x raised to 4. These are the values of phi1. If we put alpha is equals to 0 to 4, this is for even alpha, alpha is equals to 0 to 4, then we get a phi1. But see this, phi1 can be obtained from this relation. Now we can write the according to the solution, that is phi1 of x. If we put in that phi1 of x, if we put x is equals to alpha is equals to 0, alpha is equals to 0, then we get 1. आणि अल्फा इज इक्वल्स टू 0 ठेवल्यामुळे पहा, नीट लक्षात घ्या, अल्फा इज इक्वल्स टू 0 ठेवल्यामुळे हे टोटल टर्म 0 होतो. So we get the phi 1 of x is equals to 1 here. If we put alpha is equals to 2, अभी देखो मैं यहाँ पे alpha is equals to 2 रखता हूँ. If we put alpha is equals to 2, then what will happen? 2 minus 2 means 0. Next all term goes to 0. कारण 2 minus 2, 2 minus 2 नंतर 2 minus येणार, बाकीच्या सर्व टर्म 0 होतात. इतर राहतं 2 plus 1 means 3. 3 into 2. See this. 2 plus 3 means 3 into 2 divided by 2 factorial means 4 of x square. That is 1 minus 2 on the 2, 2 to the 4. So we get 1 minus 3x square divided by 2. Is it correct? So, 2 कसा आला रे? If we put alpha is equals to 2, 2 factorial म्हणजे 4 नाही, 2 येतो. सॉरी, इथं चुकला आपला. 2 factorial means 2. बरोबर आहे का रे स्टुडंट्स? 2 factorial means 2. 2 will be get cancel. Then this becomes, देखो, if we put alpha is equals to 0, then we get alpha 1, phi 1 of x is equals to 1. हे बाकीच्या टर्म सर्व 0 होतात. If we put alpha is equals to 2, then we get phi 1 of x which is equals to 1 minus, बरोबर है सद्दाम, you are correct. 1 minus, यहाँ पे देखो 2 plus 1, 2 plus 1 into 2 divided by 2 factorial into x square. Remaining terms are 0. This goes to 0. Next term goes to 0. Third term goes to 0. Means remaining terms are 0. That means 0, 0, whatever may be. So we can write 1 minus, that is 6 divided by 2 into x square. So 1 minus 3 into x square. So we get the phi 1 of x is equals to this. Do you understand that? तुम्हाला समजलं का रे phi 1 कसं काढलं? Phi 1, phi 2 we will get the polynomials if we put alpha is equals to 2. Okay. Now also we can put phi 1 of x if alpha is equals to 4. आता इथं काय करणार तुम्ही? alpha is equals to 4 जेव्हा ठेवाल तेव्हा जी नेक्स्ट टर्म येणारी असते 4 टर्म, त्या पुढच्या टर्म, आता याच्यानंतरच्या ज्या टर्म्स येणार आहेत त्या 4च्या सर्व 0 होतात पुढच्या, आणि मग त्याचं पॉलिनॉमियल असं येतं, लक्षात ठेवा. 1 minus 10x square plus 35 by 3x raised to 4. You can put, आता तुम्ही हे पुटअप करा, लक्षात ठेवा. समजतंय ना? जास्त डीप मध्ये जायची गरज नाही मला वाटतंय. ओके, यू कॅन पुट दिस. नाउ thus the solution phi 1 is not a polynomial in this case since none of the coefficient in the series of 8.8, this 8.8, see this equation 8.8 of the series 8.8 vanish. A similar solution occurs when alpha is a positive odd number. Then we can get phi 2 of x as a polynomial. Now see this. Now if we put alpha is equals to 1, alpha is equals to 2, if we put alpha is equals to 1, similarly process. If we put alpha is equals to 1, then phi 2 of x is equals to, first term is x minus alpha is 1, 1 minus 1 means 0, second term 0, third term 0, means which gives a 0, 0, 0, 0 in this way. Plus 0, minus 0, plus 0, minus 0. We get, so alpha 2 is equals to x. Phi 2 of x is equals to x. If we put alpha is equals to 1. So, we get relation this phi 2 of x is equals to 1. Similarly, phi 2 of x is equals to alpha 3. Phi 2 of x is equals to, we can put this for odd terms. You can put for odd terms. Hell, note that student, Legendre, solution of the Legendre equation, in this way we can obtain phi 1, phi 2, phi 3 in this way. समजलं का सोल्यूशन कसं काढलं? हे खूप मोठं आहे, लेंदी आहे, पण काही अवघड नाही आहे. तुम्हाला ती series expansion समजली पाहिजे. So we get the values. Okay. Saddam, समजलं का Saddam? Do you understand this, Saddam? So we get phi 2 of x is equals to x when alpha is equals to 1. Phi 2 of x is equals to x minus 5 by 3 x cube if alpha is equals to 3. Then phi 2 of x is equals to x minus 14 by 3 x square plus 21 by 5 x raised to 5 if alpha is equals to 5. हे आत्ताच लिहून घेऊ नका तुम्ही, फक्त आता समजून घ्या, नंतर व्यवस्थित लिहून घ्या. ठीक आहे. Now we shall consider a particular example. If we put alpha is equals to n. आता हे मात्र इथपर्यंत कंप्लीट आहे, सोल्युशन हे संपत आहे इथं. दिस इज द एंड, हेन्स प्रूव्ड. Hence we can obtain the solution of Legendre equation. See this, we can obtain the solution of Legendre equation. Now this is for special case or note. Special case. It is the special case. If we put alpha is equals to n, अभी क्या करना है आपको? If we put alpha is equals to n, then Legendre equation can be written in terms of n because n is a non-negative integer. The polynomial solution Pn of degree n. So we can write this Legendre equation, we can write 1 minus x square y double dash minus 2x y dash plus n into n plus 1 into y is equals to 0. That means in the Legendre's main equation you have to put alpha by n, then we get the equation 8.9. This is the special case of the Legendre polynomial. So satisfying Pn of 1 is equals to 1, Pn of n is equals to 1 is called nth Legendre polynomial. In order to justify this definition, we must show that there is just one solution for non-negative integer. This will be established by way of slight detour, which is the interest of ourselves. So we get phi is a polynomial of degree n, then we can write phi of x is equals to dn divided by dx raised to n x square minus 1 bracket raised to n. Phi satisfies the Legendre. आता हे जर इक्वेशन तुम्ही याद ठेवलं nth order, then we get the equation 8 minus 9, 8.9, then we get u of x is equals to x square minus 1 bracket raised to n. So u of x is equals to, we can write this, u of x is equals to x square minus 1 bracket raised to n. To obtain the differentiating, we can write according to the theorem number 9 and 8, we can find the solution according to the theorem 8 and 9 by taking u1 phi 1 plus u2 phi 2. In this way, u1 phi 1, u1 in this way, u1 dash phi 1 dash, u2 dash phi 1 dash. In this way we can obtain the solution. So we can write, आता याचा differentiate करा. After differentiation, this we can write this differentiating expansion n plus 1 times, then we get this relation. हे फक्त रिमार्क आहे तुम्हाला अंडरस्टँडिंग साठी. झाला अंडरस्टँडिंग तर समजून घ्या, नाही झालं तर चालतं, असं काही नाही, याची गरजच नाही आहे. It is not necessary to know this special case, but I want to try to explain special case of the Legendre polynomial, Legendre's differential equation also, but it is not necessary for you. So since phi is equals to u raised to n, then we can obtain the solution of the Legendre's special case 1 minus x raised to x square phi double dash of x minus 2x phi dash of x into n minus n plus 1 phi of x is equals to 0. And we have shown that phi satisfies the equation 8.9, means special case of Legendre equation. It satisfies, therefore phi 1 of 1 is equals to 2 raised to n minus 1 n factorial. Thus we get the solution phi of x is equals to this. This is the factor. तुम्ही सॉल्व करा, समजून घ्या, समजेल हे तुम्हाला. phi 1 of x is equals to this. Now it is clear that Pn of x given by, so we get the final answer Pn of x is equals to 1 upon 2 raised to n divided by n factorial dn divided by dx raised to n x square minus 1 bracket raised to n is the nth legendary polynomial, provided we can show that there is no other polynomial solution of equation 8.9, means special case of legendary polynomial at which is 1 at x is equals to 1. Suppose psi is any polynomial of solution 8.9, then for some constant c must have psi is equals to C1, or psi is equals to C2, according to the n even or odd. We can have the solutions phi1 and phi2 from 8.7 and 8.8 we have seen. Suppose n is even, then we get the solution psi is equals to C1 plus d into phi2, and we get for some constant c and d, we have considered in place of c1 c2 or c0 c1, we have considered another constant, that is c and d constant coefficient for the solution phi1 and phi2 from the basis of the solution mod of x less than 1. But psi minus c into phi1 is a polynomial, whereas d into phi2 is not a polynomial. In the case d is not equals to 0, and hence we get d is equals to 0. In a particular function p of n given by 8.10, p of n is equals to c into phi1 for some constant c if n is even, and thus we get p1 is equals to pn of 1 is equals to c1 phi1, and according to the equation 8.9 we can write the first pure Legendre polynomial p0 of x is equals to 1, p1 of x is equals to x, p2 of x equals to, we can write this, and in this way we can obtain the Legendre polynomial. This completes the special case of Legendre polynomial. See this, ते फक्त special case ही फक्त Legendre polynomial obtain करण्याची आहे. By using this special case we can find the Legendre polynomial, differential equation solution ची नाही. So this is actually, this completes the proof of Legendre polynomial. इथं हा Legendre polynomial चा proof संपतो. तुम्ही पुढचा पार्ट नाही केला तरी चालतो, तो रेफरन्स पार्ट आहे, एक्स्ट्रा माहितीसाठी पार्ट आहे, जे रिसर्च मध्ये जाणार असतात स्टुडंट, जे रिसर्च मध्ये आहेत, जे PhD वगैरे करतात, जे Legendre polynomial PhD करतात, त्यांच्यासाठी त्यांच्या पॉलिनॉमियलची गरज असते, म्हणजे हा पुढचा पार्ट आहे. That is research part. The special case of Legendre polynomial is used in the research work, in advanced work. You are not necessary to that, so you can write here up to. Okay, काय ओके. तर हे नोट व्यवस्थित लिहून घ्या. सद्दाम सारिका यस. तर इथं थांबू. जरी इफ यू हॅव एनी डाऊट रिगार्डिंग धिस, if you have any doubt regarding this, then you can ask me. You can ask me. You can come in college. You can ask. I can tell you in detail, clearly one and each step. Okay. You can call me. I shall explain this term clearly, each and every step. Okay. If you have any doubt in a single step, then you can call me. I will explain on phone also for this, because this is a difficult relations. Legendre polynomial is a particular relation. It is a difficult relation. Solution of the differential equation with analytical coefficient, this is a particular relation. Because why it is a difficult, why it is hard to know, because we have to write in the expansion series form. We have to convert in the expansion series form, so it is difficult. Okay, now we shall stop here. Namaskar, goodbye.